So now we are live, which means that if you're sitting at home right now because you can't make it to school, you could be watching the class. You could be participating along. How awesome is that, huh? Of course, lucky for you, you're not. So, Desmos, let's clear that. Okay. You can see that. Good. We pull down the screen. Really? Oh, sometimes I throw all these things away. Okay. So this is what it should look like. If it doesn't have this, then that little double arrow will collapse or expand that sidebar. That sidebar is where you're going to do a lot of your work, though, so you definitely want to leave it up there. Right here is where you just type in an equation, and all you do is I'm just going to type in y equals, and I'm going to just type in y equals 2x squared minus 3 and hit enter. Boom, there's my graph. Now, a few things you probably need to know. How do you type in a squared? A little V shape, it's called a caret. It's right above the 6 on your keyboard. That's a to the power of symbol in math. Now, you got to be a little bit careful here, because if you type in x to the power of 2 minus 3, it wants to leave the 2 minus 3 in the power sometimes. So everybody type in x to the power of 2 minus 3. Does it leave the 2 and the minus 3 all in the power, or does it put the minus 3 down? It does put it down? Okay, for you? Okay, here's the deal. Sometimes it won't. Sometimes it'll leave stuff in the power because you may want a longer power. What you got to do to get out of the power, sometimes you got to just be careful. Make sure it puts in exactly what you want. Just the right arrow on your keyboard. When you're done typing the power, you just hit the right arrow. It'll move it out of the power, and then you can continue typing more equations. Okay, so that right arrow to get out of some special function. Next thing, how do you put in a square root? Well, SQRT will create a square root symbol for you. Everybody type SQRT at the beginning of the next line. Boom. You got a square root symbol. Now you can type stuff inside the square root symbol. Again, when you want to get out of the square root symbol, you got to use the right arrow key to move over, because then you're moving out. It will just continue to extend that square root symbol as long as you type until you stop and move out of there. You also have the option, there's a keyboard. Look at the bottom left corner of your screen. See a little picture of a keyboard? Click on that, and a lot of really basic functions are right there in that keyboard. Everybody see the little keyboard, bottom left corner? Okay, good. I'm seeing some heads nodding. That makes me feel better. One of the things I like about algebra too, my algebra classes, half the time they're too scared to nod because they're freshmen. You guys remember being freshmen? And they sit there and they just stare at me. I'm like, did you see it? They just stare at me. Then I have to say, if you saw it, move your head up and down like this, and then they'll about half of them will move their heads up and down. So if we click on that little button down in the corner that looks like a keyboard, we get, and you can see I've already got the keyboard. You can hide the keyboard, you can bring the keyboard up. Basic functions right here, and then over here you got some buttons that'll bring up more functions, many of which you've never heard of. Don't worry about them. If you need one specifically, I will tell you that it's there, but there's some stuff from stats, so that's Mr. Schick's class. There's just different kinds of distributions, which is also stats. Miscellaneous, there's some good stuff in miscellaneous. There's a fraction button. There's an nth root button, so if you're doing things other than square root, you can use that one, which is sort of nice. And then there's some other stuff that we'll never use, but are cool functions for some interesting things. If you find that kind of thing cool, which I do. All right. Everybody click the little gear icon up here. Notice that when you click the little gear icon, it gives you the option of making a table. You can click right there. It'll just make you a table for that function. So when I click on that, it'll make a table. It'll actually turn the equation into a table. Notice that it changes the graph. It puts dots on the graph just because it's now plotting the points as well as the curve that connects those points. What do you do if you don't want it to be a table anymore? Well, you're sort of out of luck. Once you make it a table, I believe you have to then just delete it and type it back in again if you want the table to go away and you just want the equation. So the graphing calculator is actually a little bit easier when it comes to tables because the graphing calculator, it's easier to move around. How do you move around in the table? You click on somewhere on the table and then, well, then it doesn't. I thought you just arrowed down. Huh. Well, there you go. You can play with it and figure it out. How about that? Because it's not. Oh, there you go. If you type in a value and hit enter, now it says, oh, you want to make the table bigger. So I typed in the 3 and hit enter on my table, and it filled in the 3, but then it also created 4. And now every time I hit enter, it just scrolls down on the table. Yeah, the table feature's nice, but it's not great. It's nice for a quick, oh, I can get a table. Again, next week we'll be talking about the graphing calculators. I'll show you how to do it with the graphing calculator, and it's way easier, way more powerful than the graphing calculator. Any questions on any of these controls so far? Okay, I have. Why don't you go ahead and move up with him since it looks like this is it. I've got a whole bunch of equations, and here's what I want you to do. You are going to put your equation into your grapher. I think I will have you just work with the book behind you, so you don't have to work on your own. So I'll have you just turn around and work with those two. Okay. You're going to put the equation into Desmos. I want you to come up with as many interesting and useful facts about your equation as you can. Write them down in your notebook. You're going to put your equation in your notebook because you're going to need that equation tomorrow and you won't necessarily have this little slip of paper anymore. As many interesting facts about your equation as you can. And then I'm going to give you about 8 to 10 minutes to discuss this with your partner to get as much down as possible to play around with Desmos. Then we're going to have a class discussion and we'll make a list of the kind of things we came up with. And then from there, I'll give you a little bit more time to go back and find some things that maybe you didn't find the first time that somebody else said, oh, we did this when we were exploring. All right? So, equation. I have enough. I thought I counted enough. And I was making these equation. Oh, look at that, I did it. Oh, exactly enough. All right. Have you guys met Mr. Tomato? Mr. Tomato keeps time for me. It's his job. So let's set it for 8 minutes and we'll see where we are. You'll know when time's up. He'll make a loud ringing noise. That's all he does. All right, I should hear you talking. Make sure once you put your equation in, you compare with your partner. Do you have the same thing? If your graphs are look different, then you didn't put the same thing in.
Oh, mine is doing. Yeah, yeah. It looks like a slot.
Oh, by the way, if you haven't realized this yet, you can put two fingers on the screen and put your fingers wider apart, closer together. It will zoom in and out. And if you mess it up so much you can't figure out how to get back, push the little home button that's on the right-hand side of the screen. It's only there if you change something. Little tidbits that I will tell you as I remember them. At this point, you might want to push the little home button. It'll take you back. Once you get far enough away, and you're like, or maybe that's what you were saying. So see your vertical scale, you're going by thousands in your vertical scale, but by ones. And so once you go high enough, it looks like it's flat. Uh-oh. You get your equation in there wrong. What's the difference between what you got on your screen and what's on the paper?
Because then it like just underneath.
Yeah, it's gotta be outside the square root, and that's gonna change your graph a little bit. There you go, perfect. And look at that, move it down a bit. Looking good. Good. Be right there, Hexon. Let me just check these guys' graphs and see how we're doing. All right, looks good. Yeah. Everything's gonna go in your notebook. But remember, the goal here is just as many things as you can figure out about this function, this graph, as you can. So anything that you look at, you think, oh, well, that's interesting. Discuss it together, jot it down. Cool. All right. All right, looks good. Like your equations. We discussing? Oscar, you don't think that you're writing things down? So let's talk to Jasmine. I'll give you another minute or two because it looks like everybody's still working. Talk to Jasmine, find out what she's writing down. Maybe flip your notebook over so you got somewhere to put these things. All right? Oh, yeah, you got that? Oh, let me grab my pencil. All right. Thank you, Tyson. And you check it against the key there. Make sure you do that. 'Cause that's sort of half the important stuff is making sure you actually knew what you were doing. Josh.
Yeah.
Yes, absolutely. There's a little notebook right in that front thing. Just sign it out there when you go. All right, where were we? Okay, about 30 more seconds. Question for you. Does that really start right there on the axis?
Oh.
Ah, that's probably important. Cool. Let's talk. Second period. Just for fun. Well, I guess I could figure that out as we go along. I need to make sure I get Josh in there. Tell you what, Hunter, when he gets back, did you ask him to print his name on that? Thank you. All right, here we go. One interesting thing, Oscar, one interesting thing that you guys were looking at on your graph. Oscar, go.
No. No.
Pass. Oh, Jasmine.
You said it doesn't look like the U shape.
So it is not U-shaped. You said doesn't or does? Doesn't. Okay, so not U-shaped. So I want to pick your brain a little bit here because no, this is good. This is a good observation, but here's what I don't like about describing something with what it's not. If we say it's not U-shaped, I could also say it's not A-shaped, it's not B-shaped, maybe it's not C-shaped, it's not D-shaped or E-shaped or F-shaped or G-shaped. See where I'm going with this? And I know U-shaped is a particular, thing. We don't use all the other letters of the alphabet, so I'm sort of, exaggerating a little bit here. But the problem with describing what something is not is when there are so many possibilities. If you try to describe something with what it's not, you could pretty much go forever. It's not this, it's not that, it's not this, it's not that. Jasmine, what does it? What could you come up with one word that would sort of explain the shape? Is it a line? Kind of. So it's looks just like this, perfectly straight. Okay.
A little curve at the end.
There's the word I'm looking for. There's the word I like, curve. It's curved. This is nicer because it tells me something. It doesn't tell me what it's not. It tells me what it is. It's curved. This is a great word. Cool. Thank you, Jasmine. Jasmine, what direction does your graph curve? Is it curving up or is it curving down? Curving down? Does anyone have one that's curved up? Show of hands. So it goes like this versus like that. Quite a few of you. Oops, I almost wrote curve down again. Guys, that's a really nice descriptive word. It's curved up or it's curved down. The only other possibility would be linear. It's a line. And since none of these are linear, we're all going to have to choose between curved up or curved down if we're going for a description of our graph. Cool. Thank you, Jasmine. Landon.
Yeah.
Something else you noticed.
Ours isn't an infinite one.
Not infinite. Well, we're going to the knots again. Well, okay, thing one. I'm going to address two things Landon said, and then I'm going to ask him some more questions. Thing one. Line. Is this a line at all? That's a big deal to somebody who's into math. There is no such thing. People will say to you, oh, my graph is a curved line. Yeah, no, it isn't. It's either a line or it's a curve. It can't be a curved line because then it's not a line, right? These are two completely separate things. A line doesn't curve. Anyone who says curved line, just sort of look at him weirdly and then walk away. It's not a person you want to know. So, not infinite. Landon, let's talk about not infinite. What do you mean by not infinite?
Like it starts on the graph and then it goes down that way forever.
So it's infinite in one direction, but not in the other direction, and it has a starting point. Cool. Do you know where yours starts, Landon?
-9, 4.
I'm going to leave that open because that's going to be different for every single team. Infinite away from starting point. What direction is yours infinite, Landon? Uh-oh. Sorry. If I do that by accident, knock. I forgot to put the little latch that would keep the door from being locked. Just knock. It won't bother me. Sorry about that. Which direction is yours infinite?
Down and to the right.
Down and to the right. Anybody's infinite up and to the right? Show of hands. Okay, I see a couple of hands. So it could be up and to the right. Anybody infinite down to the left? Show of hands. Okay, anybody infinite up to the left? Yeah. There are 4 possibilities. It's either going that way forever, or that way forever, or that way forever, or this way forever. So we can now narrow down your graph because you could say it starts here, it curves up or down, and it goes one of these 4 ways. Up right, down right, up left, down left. If I tell you those 3 pieces of information, or maybe you want to call it 4 pieces of information, 1, 2, 3, 4, you should be able to sketch my graph, shouldn't you? I want everybody to sketch the following graph. On your paper, rough sketch, doesn't have to be super accurate, starts at -3, 4, curve up, goes down to the right. Dry sketch that starts there is curved up and goes down and to the right. Everybody, Donald, where's your notebook, your pencil? Get them out. Notebook, pencil. You're sketching this in your notebook with your pencil. Or your pen, I don't really care. Starts at -3, 4, is curved upward, but goes down and to the right. When you have your sketch drawn, compare with your partner. Does their sketch look sort of like yours? Does everybody have a sketch that looks something like that? It's going to cross the axes in different places. It may be steeper, it may be less steep. But your sketch should look something like the one I've got up on the board there. Notice it going down and to the right. My arrow's going that direction. And notice it's curved upwards. It's got that open curve to the upward side, as opposed to being curved downwards where it looks like this instead. Did anybody else find any more information about their graph? I'll take a volunteer here because not all the graphs have all the same information or the same things that you'd be looking for. Anything we're missing on the board here that you found about your graph? Volunteers? Anybody? Jim?
Starts positive, depends on the negative.
Okay. Okay. So here's a question. That's a good observation. Can we tell that that's true based on these things? Yeah. So it makes sense that if I know where it starts and I know what direction it's going, I know that it starts in the positive, ends in the negative. And when we say ends, we mean the bit we see. But yeah, it's always going to keep going down. So it's a good observation. But we can actually, you guys know the word infer? Some of you are nodding. Yeah, infer means figure things out from the given information. If I tell you that this starts in the positive and goes downwards, we can infer what Gio said. So it's a good observation. What else? What other pieces of information? Just looking at the graph that I sketched on the board, what are two pieces of information that you might look at and say, oh, look, I can figure out this. Anybody? Be brave. Put up your hand and say it. Gio was brave, and he had a good idea. You got to put up your hand and say something. You can't make that. Nothing? Nothing? Okay. Here, let's try this. Talk to your partner. There's two more pieces of information right there staring you in the face. If you look at my graph, the one on your computer might not have these two pieces of information depending on what your graph looks like. Talk to your partner. What am I talking about? What are some more things that maybe I could write down about my graph? Go. All right. Now, anybody feel a little more brave? You talk to your partner said, oh my gosh, that's a great idea. You should totally say that when Mr. Armerding asks. Anyone? Anyone? Come on. Come on. Oh, you're gonna do this to me? This is how we're gonna play the game? I don't want to just stand up here and tell you stuff. I know you got something. Somebody's sitting back there going, I don't want to say it because it might be wrong. I want to say it. Yes.
It crosses the X and Y axis.
Boom! Yeah! It crosses the X and Y axis. Nice. Intercepts. What?
Oh, I just told Landon that's what I said.
Yeah, but you weren't brave. Next time, be brave. Guys, this is great information. X and Y intercepts, because think about what I asked you to sketch. I gave you starts at, curves, direction it goes. If I'd given you X and Y intercepts, we might have discovered that, oh, well, it actually crosses the X and Y axes up there and it looks more like that. Or it crosses the X and Y axes down here and looks more like that. really narrows down what my graph has to look like with just that one little extra bit of information. Where does it cross the axes? And we are going to call this the X and Y intercepts. Add that to your list, everybody. Writing that on your list, X and Y intercepts. Now, your graph may not have X and Y intercepts. Geo mentioned that his graph started in the positive and then ended in the negative, which means he has to have at least one intercept. He has to cross the x-axis. Maybe he crosses the y, maybe he doesn't. We don't know. But if you started in the negative and went negative to the right, hey, look, no intercepts. But that's also an important bit of information, because what you're going to say when you do your investigation is you're going to say none. Under the question, what are the X and Y intercepts? There aren't any. None. Because you just told your reader one more useful thing. Doesn't cross either of the axes. All right? Questions? Okay, let's talk about this vocabulary, curved up and curved down. We've got a special word we're going to use. How many people have heard the word concave before? A few of you? Okay. So here's the deal. Concave tells you something about the direction that it curves. Concave is this side of a curve. It's the side that looks like a cave. Caves are holes, right? You can shelter in a cave. A bear can come charging out of a cave. You can run. Concave means the side where it's curved like this. It's curved inwards. Now, the other word that we're never going to use is convex. Convex is the back side. But we're never going to use convex, because if we use convex, we have to remember two different words. We're just going to remember one word, concave. And there are two possibilities. If it is curved down, we're going to say concave down. And if it is curved up, we're going to say concave up. The cave is opening downwards, or the cave is opening upwards. I want you to jot those down. I want you to get out a highlighter, and I want you to highlight those, because that's vocabulary you may not have known. But this is what we are always going to say when we describe a curve. It is either concave up or concave down. Can't be anything else unless it's not a curve. So writing this down. Josh, there's graph paper over in a tray on the back if you want to grab a piece just to make some notes for today. So one, when I say investigate, we want to know the concavity. This is going to be part of the description. Two, a starting point. Three, let's talk about up and down. We're actually going to say increasing or decreasing. Because again, if we all use the same language, it gets super easy. Down will be decreasing. Up will be increasing. And then, of course, you'll still have to say to the right or to the left. And then finally, you will identify if they exist, the X and Y intercepts. And if they do not exist, what will you do? Anyone? What will you do? X and Y intercepts do not exist. You say?
None.
None. Good. Yeah, you say none. Here's why we do that. Because you could argue, well, but Mr. Armadang, I mean, my graph started at 4, -5, and I said it was decreasing to the right, so of course it doesn't have X and Y intercepts. Well, that's fine. But if you don't point out that there are none, I don't know whether you just forgot and maybe there are, and now I have to think about it. I don't want to have to think about it. I want you to tell me this is my function, Mr. Armading. This is what it does. It doesn't cross the X, Y intercepts. And then I can say, oh, okay, cool. I know it because you told me. Instead of, oh man, they forgot to tell me the X and Y intercepts. Now I got to go figure them out. And then after I figure for a bit, I'm like, oh wait, there aren't any. Ah, wish they told me that to begin with. Sure would have saved me a lot of time. We want to tell our reader as much information as possible. All right? Questions? I know if you won't volunteer perfectly good information, you're probably not going to stick up your hand up and ask a question because you'll be like, oh man, if I ask that, everybody's going to think I'm stupid. It's not true. If you have a question right now related to this math, I'd be willing to bet good, hard cash money that there's 3 more people in the class who have the exact same question, but they're also too nervous to ask. Got a question? Now's your chance. All right. Let's talk about X and Y intercepts. X and Y intercepts are points on a graph. Your graph may or may not have them, doesn't matter for now. But because they are points on a graph, I can write them as coordinates. Agreed? Every point on a graph can be written with both an X value and a Y value. Here's what I would like you to do. I would like you to talk to your partner. And can you tell me, figure out, do we know one of these numbers for all X intercepts? And do we know one of these numbers that would be true for all Y intercepts? Probably something you've seen before, but we'll have to go ahead and pull it out of our memories, or maybe just figure it. Do you need that? Oh, you're plugged in right now. Okay. So, what do we know about X-intercepts? Can we fill in one of these spaces for all X-intercepts? What do we know about Y-intercepts? Can we fill in one of these spaces for all Y-intercepts? Discuss with your partner. We give you about a minute and a half max. Go. Here, I'll give you a little bit of a hint. Think about where on the graph they are. Where do you find an X-intercept? Where do you find a Y-intercept? Go. All right, you've all stopped talking, so either you thought, oh, he's writing something interesting on the board, we'll stop talking about X and Y intercepts, or you'd already figured out the answer. I'm gonna go with number 2. You'd already figured out the answer, so I'm gonna have to call on somebody in just a second. So, could be any of you be thinking, what am I gonna say when he calls on me? In the meantime, I'm gonna take a short break from math to point out, first time this year, your lunch on Thursdays is based on your 5th period teacher, not your 4th period teacher. Now, confusing, but the alternative would be we don't have 4th period today, nobody gets lunch. Instead, you just have a 110-minute 5th period with no lunch. I don't think that sounds fun. So lunch is going to be based on 5th period. There is a list right here of who has what lunch. Okay, none of you were in my 5th period class, so it doesn't do you any good to know that I had second lunch. But there you go. You might want to look at this list at some point. Here, let's do this. Everybody know who they have for 5th period?
Yeah.
Got that in your head? Okay, I'm going to read these. Ready? First lunch, which means that you go straight to lunch after homeroom. Mrs. Ames, Brubaker, Hutchinson, Killian, Kurz, Lawrence, Van Dyke, Wiley. Sounds to me like this whole end of the upstairs plus a few others. That's first lunch. If you don't have one of those people, you go to 5th period after homeroom, and then they'll tell you when it's lunchtime. That way I don't have to read the rest of the list.
Wait, we go where?
5th period. If you do not have one of those teachers, those 8 teachers for lunch, or for 5th period rather, then you go straight to 5th period. If you have one of those 8, you go straight to lunch after homeroom. Cool. You'll get used to it. And then they'll change it. Because then we won't have to have 3 lunches anymore and the whole thing will change. Got my fingers crossed. Quick as possible. All right, here we go. X and Y intercepts. When I call your name, you can pick one and tell me about it. Sienna, pick one and tell me about it. What do you know?
X and what? It's always going to be 0 for the Y.
Does it make sense that if I am on the x-axis somewhere, I have not gone up or down at all? And that's what that second number tells you. The first number tells you how far did I go back and forth. The second number tells you how far I went up and down. And if I'm sitting here on the x-axis, I haven't gone up or down at all. Which means that that's always going to be 0. Cool. Thank you, Sienna. Mallory. Who's Mallory? Mallory, talk to us about the Y-intercept.
The X place will always be 0.
The X place is always going to be 0 because the opposite of what we did before, the Y-intercept, we're somewhere on here, which means we haven't gone left or right at all. We just have to go up or down, which is the second number. Guys, this is going to be super useful down the road as we start to look at functions and say, well, hang on a second. If I'm looking for the x-intercept, I know y is equal to 0, so I can plug a 0 into my equation. And now I just got to figure out what the x value is. Same thing for the other one. I want to know the y-intercept. Oh, I just plug a 0 into my equation for x. Now I know where the y-intercept is. All right. In case you're wondering why I finish something and then pause, remember I told you that I'm going to be figuring this out as I go along because I don't know how much you know or how long things are going to take to begin with. And so then I'm figuring out, okay, which part do I want to do next? Here's what I want to do next. There are 4 possible shapes of graphs. The 4 possible shapes are 1, 2. Oh no. There's 8 possible shapes? 3, 4, 5, and 1, 2, 3, 4. Agreed? I can be concave up. 1, 2, 3, 4 concave up graphs. I can be increasing or decreasing. There's 4 increasings, 4 decreasings. And I can be going to the right, 4 graphs, or to the left, 4 graphs. Those are the only 8 possibilities. Now, where you start could be all over the place on any of those. We're going to ignore the where you start part. Okay? What I want you to do is I want you with your partner to look at your graph and decide, let's call these 1, 2, 3, 4, 5, 6, 7, and 8. I want you to decide with your partner which of those you are. And I want you to draw a little picture, doesn't have, not a graph, just a little sketch, just like I did, of the one that you are and put the number next to it. So talk to your partner, which of those 8 is you? I'll be right back. All right, is everybody there? Okay, here's what we're going to do. We're going to take 5 minutes and we're going to walk out into the lounge. And I want you to find every other pair that's in the same category as you. Okay. So step 1 is all groups with similar graph. Step 2 is I want you to have a discussion with your new larger group. And the discussion you are going to have with your new larger group is, what was it about our equations that made our graphs different, even though we're all in the same shape group? Okay, so all groups with similar shape. And step 2, what is different and why? Different. There's an E right there. So here's what you will need. You will need your notebook and your pencil. Because as you sit around in your group having this discussion, I want you jotting down some notes. It's going to be a short discussion. We're going to have 5 minutes total. You should be able to find everybody with your shape group in the first 2. That leaves you with 3 minutes to discuss, why are our graphs different? What is it about our equations that gave us different graphs? And do we be thinking about patterns? Okay? So, notebook, pencil, everything else stays behind. Into the lounge. I'm going to go shut Mr. Schick and Mr. Brandon's door so we don't distract. All right, here we go. Yes, that is a true statement. I think we'll pick this discussion up. Thank you for reminding me because I had lost track. I think we will pick this discussion up later. So remember, third period now, then homeroom, and then lunch or fifth period. No fourth period today. Have an awesome day.
Thank you.
You're welcome. Have a great day. Does everything make sense, Josh, so far?
Yeah.
Cool. I invited you to the Google Classroom, so next time you go in, there'll be my class, and it'll say you're invited. Do you want to join?
Yeah, I joined already.
Oh, you already done it? Sweet. Good. Oh, thank you very much.
Usually we did the one with Desmos.
Yeah. Yeah, your graph.
Yeah, my bad.
Yeah.
So, the one I'm starting with, the one that he gave us to put on Desmos, was like -2 square something. The ones he gave us, mine was like this. And so I don't even see any of them. And I thought we were doing, it was a different equation. I thought mine was like 5. Because
Yeah. No, that's fair. So, I'll say it shouldn't have. It should have looked more like it couldn't go down and then back up again because of this function, which we haven't really even talked about. But so what you were looking at, whichever one you were looking for, would be one that was curved upwards. There's your concavity, and was increasing to the right. So, and it's not that big a deal. I mean, it's a discussion starting point, and it gave us an opportunity. My main thing there was to give everybody an opportunity to sort of do a little comparing, and so it's not the end of the world, and we'll continue to talk about it. So, don't worry too much about it. All right? Cool. Have a good one.
He wants 2.2.
Oh no, maybe.
We were supposed
Yeah.
to watch all the videos, right?
I'm confused.
No, I find it more effective if